Welcome back, ladies and gentlemen. Today we're going to tackle section 5.2 using the sum and difference formulas for sine, cosine, and tangent. Each one has a sum and each one has a difference, so there are a total of 6 formulas altogether, and you can see them up on your screen right now. You do not need to memorize them, you just need to know that they exist so that they can help you through a problem. Our work today will actually cover 2 days of instruction, just like the previous video, and we're going to split up the 5.2 worksheet into problems 1 through 12 and 15 through 20 on day 1 and day 2. All of this is, again, available and posted and scheduled on the Cadera Math website if you have any questions. Here's the issue. If I ask you what is the exact value of sine of 225 degrees, that's an angle that happens to be on the unit circle. So you can go find your unit circle. You can go, okay, well, this is 225, that's 5 pi over 4, and sine is asking for the y coordinate from that location. So your answer to this would be negative square root of 2 over 2. However, if I ask you just a slightly different question, the sine of 105 degrees, you'll notice that that does not appear on the unit circle anywhere. So if I ask you for the exact value of that, it's not something you can answer. You can type it into a calculator and get a decimal answer, but you can't get an exact answer without doing a little bit of extra work. Okay, so what we're going to do is we're going to view these sorts of degree measurements or radian measurements as a sum or a difference of 2 angles that we do know. And if we view this angle as a sum or a difference of 2 angles that we do know, then we can use these formulas. Basically say 105 is a combination of, you could do it any number of ways, but 105 could be a combination of 45 and 60 degrees, for instance. You could add those together and you could use this formula right here to help you figure it out. This symbol is called alpha, this symbol is called beta. It's just kind of a stand-in for angle number 1 and angle number 2 that you're using. And you'll notice that there are 4 variations on these formulas, and they do not differ by very much. It's just a matter of which trig function is where, sine or cosine, and whether there's a plus or a minus in between each one. But basically it's a product plus or minus another product. So take a look at these formulas. There's a printout available on my website if you just want to print out a cheat sheet, or you can write them down in your notebook, whichever works for you. The important thing is that you have them at your disposal in some form so that you can reference them quickly. So if you need to print it out or write it out, pause the video and do that right now. I'll show you how to do it with a simple example right here. This is an example where everything's broken up already. So we have a known angle and a known angle, and you notice that both angles appear on the unit circle. So all you have to do is select the appropriate formula down here and use it. So I see a sine and I see a subtraction. So I'm going to use the second formula right here, and I'm going to write it out with that being angle alpha and that being angle beta. I'm not going to consider that a negative pi over 4. I'm just going to consider it a pi over 4 when I write this out. So if I do that, sine of alpha, alpha was 2 pi over 3, cosine of beta, beta was pi over 4, and just continue with the formula as written out right here. Okay, so we have 4 separate little evaluations to do using the unit circle. Here's where you have to be really diligent in using your unit circle correctly, because if you make a sign error, or if you even get one of these problems, little mini problems wrong within the context of one problem, the whole thing will be wrong by the end of it. And just be really careful when evaluating your unit circle. So maybe have it out when you're doing these problems. But go ahead and evaluate every one. Go find the y coordinate at 2 pi over 3. Go find the x coordinate at pi over 4. Go find the x coordinate 2 pi over 3, and go find the y coordinate at pi over 4. Plug those values in. These two things are being multiplied together, then there's subtraction in between, and then multiplied together with subtraction in between. So we got some fraction multiplication to do. Square root of 3 times square root of 2 is square root of 6, and 2 times 2 is 4. Over here, we're just going to take a negative times square root of 2 up top, and we do have a double negative right there. Notice that the denominators are identical, so we can just go ahead and add those together, basically. And there's your final answer. You don't take it any further than that. You can't combine the square root of 6 or square root of 2. They're not like radical terms, so you can't combine them. You also cannot divide by 2 because the 6 and the 2 are inside of a radical. That's a different sort of number than the integer in the denominator. But if you were comfortable with that previous problem, why don't you go ahead and pause the video and see if you can work this one through all the way through. If not, here's the way we do it. Here's cosine. I see a plus sign, so I'm going to select the appropriate formula down here. Right here I see a cosine and a plus sign, so I'm going to write down cosine alpha times cosine beta minus sine alpha times sine beta. Put all those numbers, so that's going to be my alpha, that's going to be my beta. Put it in the appropriate spot, basically substituting it in, and then I'm going to take out the unit circle. and evaluate each one of these 4 items. So right here I'll have negative square root of 3 over 2. Right here I'll have square root of 2 over 2. Right here I will have, what will that be? That will be negative 1/2, and that will be square root of 2 over 2. Okay? Plug in all those numbers, and again, just multiply straight across. The radicals you can combine when you multiply them, not when you add them, but when you multiply you can. And it looks like this. We again get a double negative. Notice how many negatives are popping up, so you have lots of opportunity to make a little sign error. And check out the answer, that it's very, very similar to the one that we got. Basically, you're going to have a square root of 2 and a square root of 6 somewhere in the numerator. One of them is going to be positive, one is going to be negative. Maybe they're both positive, but they're going to look like really similar answers all the way through here. So the important thing is to get the sign right and the order right on each one. That's really the trick to these problems. Our next example, I went for degrees here, and you'll notice that's 105 degrees, which does not appear on the unit circle. So the challenge here is that you have to think of 105 degrees as a combination, either a sum or a difference of 2 different angles that are on the unit circle. So you think of the denominations that you can use. You can use 30, 45, 60, 90 degree angles, and you should be able to add or subtract any of those denominations together and land at 105 degrees. Now there's probably there's almost always more than one way to do this. The one that pops into my mind when I look at 105 is 45 plus 60. So if I break that up into a 45 and a 60, and then that's not going to help me out too much on a unit circle because I have all my radians memorized, but I don't necessarily know where the degrees are. I'm going to convert to radians real quick there, and then I see a cosine and a plus sign, so I'm going to do exactly what I just did on the previous problem. Go ahead and basically evaluate each one of those individually. And again, if you just check out the arithmetic, if you're still struggling with that, you'll get a square root of 6 on the right-hand side and a square root of 2 on the left-hand side, and with a subtraction sign in between. And there's your final answer right there. For our next example, I'd like you to pause the video and try to work through this one yourself. Here we go. 15 degrees is a small thing, small denomination, right? So what I'm thinking is I'm probably going to have to do a difference between 2 angles. And if you think about 30, 45, 60, and 90 degree increments, if you take a 45 minus a 30, you'll get 15. There's a few other ways to do it as per usual, but that's just the way that I thought about it. So I'm going to go 45 minus 30. And if you did it a different way, go ahead and work it your way and select the correct formula. You'll get the same answer. So we're going to use a second formula here. Convert it to radians just because I'm used to dealing with that when I go to my unit circle. And I'm using the formula in the second line. Evaluate each one. I will get a square root of 6 minus a square root of 2 on the numerator this time. Then if we start with radians, like in example 5 here, you have to think about how to break up 11 pi over 12. Now, pi over 12s are not increments that are readily available on the unit circle. However, you can think of that 11 as a sum or difference of pi over 12s. How many pi over 12s do you need to add together to get to 11? And what combinations would actually appear on there? So it could be, so for 11 pi over 12, for instance, we could split that up into a 10 and a 1. I could go 10 pi over 12 and 1 pi over 12. 10 pi over 12 would be 5 pi over 6 if you simplified it. That is on the unit circle. I could evaluate that. But the 1 pi over 12 would not work because that's just not on the unit circle. So I move on. Maybe instead, so it could be like 10 and 1. It could be 2 and 9. It could be 3 and 8. It could be 4 and 7, but 7 doesn't work because it doesn't simplify, and so on. So we want to basically break up that 11 pi over 12 into 2 increments of pi over 12 that are simplifiable and are on the unit circle. I forget which one I did here. It looks like I did 9 plus 2, okay? And you'll notice the way this works is 9 over 12 will simplify, and 2 over 12 will simplify as well. And then all of a sudden I've got angles that are represented on the unit circle, and I can punch it through with the formulas just like always. And just work it through like normal. This is what we would get. Why don't you try number 6 yourself? Pause the video right here. Okay. Pi over 12 again, there's just one of them, so if you did say a 4 minus a 3, that would work. Again, there's a lot of different ways to do it. You could do 10 minus 9. There's a variety of different ways you could do it, but I thought of it as a subtraction between 4 and 3. So 4 pi minus 3 pi is 1 pi, and then you keep the denominator the same. Those simplify to be pi over 3. Go for equation number 4 down here. So we're going to have a plus sign in between, 2 cosines on the left, 2 sines on the right, evaluate each one, simplify, and there's our... Okay, as we advance to example number 7, we're going to end day 1 instruction, so you're good to go on problems 1 through 12 on the worksheet. We're going to begin day 2 instruction right here. So this is problems 15 through 20, and there are basically 2 different types of problems. The first type is a problem that looks like this. Now there's a lot of words, so we got to make sure that we know what all the words mean. This particular problem tells us 2 things. One, we have an angle whose sine value is 12 over 13, and right away you might notice that's not a y value that's anywhere on the unit circle. So already we're dealing with something that is atypical. And the sine value of the second angle is 3 over 5. Same deal, not on the unit circle. So when it's not on the unit circle, the best strategy is to draw yourself a picture outside of that unit circle. So we're going to eventually make a drawing of this. So we got to know where these angles are located. Well, look at the next 2 sentences here. Is that alpha is between pi over 2 and pi. So they've told us that it's in quadrant 2, so they give us a location. And they also say that beta is between 0 and pi over 2, so that's saying it's in quadrant 1, and our job is to find the cosine of alpha plus beta. Now, before I get into the rest of this problem, I just want to point out that this information right here could have been told to us slightly differently. They like to use inequalities pretty frequently, and sometimes they'll just straight up tell you, hey, it's in quadrant 3 or quadrant 4 or whatever it may be. But our job is to go ahead and calculate this. So we're going to need to know everything there is to know about each of these angles, because within that formula, there's sines and cosines of both angles. So we're going to need to know everything about alpha and beta. So let's draw a picture. I'm going to make a drawing for alpha, and I'm going to make a drawing for beta. And you need to make these drawings because there's no other real way to do the calculations once we get to that point. So given that alpha is between pi over 2 and pi, and it's got a sine value of 12 over 13, I should be able to draw an angle somewhere in here. Now, if the sine value is 12 over 13, what does that really mean? Well, we have to go way back to like definition of sine in geometry terms, that it is the opposite side divided by the hypotenuse. So the opposite side, the y coordinate, or the up and down amount that the triangle is, will be our 12, and the hypotenuse will be a 13. So I can go ahead and draw a triangle in that fits that description. Now, I also want to take this information about beta and do the same thing with a 3 over 5 combination right there. From there, then we can go ahead and tackle this part of the problem, which says go calculate that. So I'm going to start with the formula that goes along with a cosine and a plus sign. And then I'm going to look at all the things that I need. I need cosine of alpha. Well, alpha is here, and I need the x-coordinate from it. Notice that it's not there. And look over here, I also need the cosine for beta. That is also missing. So you'll have to use a little Pythagorean theorem, or if you remember your Pythagorean triples, you can fill in the blanks here using that formula, or just the, 3, 4, 5, or 5, 12, 13. There's a few other Pythagorean triples that are worth knowing for this chapter. Fill in those blanks, and then basically evaluate each one of these based on your drawing. This is where the drawing comes in. There's no other way that I would have been able to do this. So cosine is adjacent over hypotenuse. Cosine beta, again, adjacent over hypotenuse. Sine alpha, which they actually gave us, and sine beta, which they actually gave us. Go ahead and evaluate those, multiply straight across, and simplify. You'll get negative 56 over 65. That was example 7. We're moving on to example 8. I'd like you to do as much of this as you can by yourself without watching the rest of the video. So if you would, please pause the video and try to at least make that drawing. The drawing is key. That's the only way that you're actually able to evaluate the expression, is off of your drawing. So take the given information, see if you can make an accurate drawing of what's going on there. If you do that, you'll end up with these 2 drawings. So that was x-coordinate over the hypotenuse, so negative 3 over 5, and they also told us it was between pi and 3 pi over 2. Beta is 12 over 13, which means the x-coordinate over hypotenuse, and it's also in quadrant 4 there. And then they ask you to find sine of alpha minus beta. In order to do that, you're going to need to know this unknown side, so you may as well use Pythagorean theorem right now while you got the triangle sitting in front of you, and then grab the formula, and then start punching stuff in. So sine of alpha, that would be opposite over hypotenuse. Cosine of beta, that would be 12 over 13, just as stated. Cosine alpha, which they already gave us, and sine of beta, which would be negative 5 over 13. Punch those numbers in, and simplify. Our next example is actually a verification, and a lot of students freak out at this, thinking that it's very, very difficult. But I think these problems are actually easier because there's less to do. All you have to do is have a little faith and follow the formula. So in this case, we're asked to verify that sine of theta plus 3 pi over 2 is the same thing as a negative cosine. Well, that seems like they're really far off, but let's use the sine with angle addition. And we'll consider this to be angle alpha and that angle beta, and we're just going to go with it. Just start writing something down that you know is true. And if you simply write down the formula with theta in the first slot and 3 pi over 2 in the second slot, this is at least a starting point that you can do. Now, we don't know what theta is, and we'll never know, but let's evaluate what we can. The cosine at 3 pi over 2, well, that's 0. The sine value at 3 pi over 2 is negative 1. So punch those numbers in, and all of a sudden you get 0 times a thing, and 0 times a thing is nothing. So we just eliminate it, and we have negative 1 times cosine theta, which will get us our negative cosine theta. So even though this looks like a very difficult problem, believe it or not, just start writing stuff down, and it will become easier. Again, here's a homework assignment. I'll see you next time.